Hi, and welcome to Meetings in Math. You are here for 7.4e, Approximating Square Roots. Our essential question is, how can estimating square roots be used to compare numbers? Today you'll need your Jaguar Jots on section 7.4, how can estimating roots be used to compare numbers? A pen or pencil, you might find a highlighter helpful. We're going to leave our calculators behind, but if you need a multiplication table or a table of perfect squares, that will be useful. Your bright ideas, your best effort, and always bring your problem-solving skills. So beginning with example number 2, we're going to approximate the square root of 23, a to the nearest integer, and then b to the nearest tenth. There's 3 questions to keep in mind when we're going to the nearest integer. And most of the time, to the nearest integer is going to be good enough. What two perfect squares is 23 between? That is usually where we want to start. So 23 is between 16 and 25. And then we want to ask ourselves, which one is it closest to? Well, it is closest to 25. And in fact, it's very close to 25. Halfway between 16 and 25 is 20.5. I found that just by doing regular averages. And so I know it's more than halfway. So then I ask myself, what is the square root of 25? And that is 5. So now I know that the square root of 25 is 5. And so I can answer the question that it's somewhere between 4.5 and 5. And usually that's good enough. But keep in mind, sometimes I do want something a little bit closer. So keeping in mind our answer to A, we're going to make a table of squares close to 23. And what we're going to do is we're going to find a spot where it changes and is one smaller and the next one is larger. And then we ask, what is it closer to? And we are going to hand do some of these answers. So 4.5 times 4.5, and I've done them for us already, is 20.25. Not very close to 23, so I'm going to keep going. 4.6 times 4.6 is 21.16. Again, not very close, so I'll keep going. 4.7 times 4.7 is 22.99. We're getting closer. 4.8 times 4.8 is 23.09. Now that is the sweet spot. This is smaller and this is larger, which means I'm somewhere between 4.7 and 4.8. So now I'm going to ask myself, am I closer to 22.09 or 23.09? Well, 23 is closer to 23.09. And since it is closer to 23.09, my answer is 4.8. So example number 3, which is greater, the square root of 49 hundredths or 71 hundredths? So before we can actually answer this question, we need to find out what the square root of 49 hundredths is, or at least a really good approximation. So when I see the square root of 49 hundredths, I'm actually feeling pretty good because the square root of 49 hundredths, I see that 49 and I get kind of giddy because I know the square root of 49. So I'm feeling okay with that. I know that the square root of 49 is 7, and by knowing that, I am hopeful that I can figure the rest of it out. Since the square root of 49 hundredths is 2 decimal places, I can divide that in half, and from there, I can actually tell how many decimal places my answer is going to have. I know that then the square root of 49 hundredths is 0.7. And I can actually multiply that out and double check it and make sure I'm okay. So now I can compare the square root of 49 hundredths versus 0.71 or 71 hundredths. So the square root of 49 hundredths is 0.7, and some of you might be able to right here do your comparison. Some of you may not be able to. So one of the things you can do is you can add a 0 to the end so you have the same amount of place numbers, and now it's almost like comparing money. Is 70 cents greater or is 71 cents greater? It makes it a little bit easier to compare decimals. Well, I know 71 cents is greater. So 70 hundredths versus 71 hundredths. Which one is greater? 71 hundredths. So our answer is 71 hundredths is larger. The big thing here was, how do you evaluate for the square root of 49 hundredths? That's really what the question was getting at. Example number 4. The radius of a circle with an area is approximately the square root of a divided by 3. Estimate the radius of a circular mouse pad with an area of 45 square inches, and then round your area to the nearest integer. So we start off with knowing that the area is 45 because they gave it to us, so we're going to write it down. And then they told us that the radius was equal to the square root of a divided by 3. And so we're actually going to write that down. We're not going to keep it up in our head, we're going to write it down. And now we can actually take this and we can substitute it in. And so now we have r is equal to the square root of 45 over 3. And we could split this into the square root of 45 over the square root of 3. But since I can't take the square root of 3, I'm not going to do it that way. I'm going to take the square root of 45 divided by 3 and do my 45 divided by 3 first. And then I get that it's the square root of 15. And remember, this is all about estimating. We're rounding to the nearest integer, we're estimating, we're getting good enough answers. So what do I do from here? Well, I'm rounding to the nearest integer. So I know that 15 is really close to the perfect square of 16. So the square root of 16 is 4, and so I'm going to call that good enough. Which means then that the mouse pad's radius is about 4 inches. So now that we've done all these problems, how would you estimate the square root of 37? I would love for you to actually explain to somebody how you would do this problem. Thank you so much for joining us in this lesson, and remember, be kind to one another because we can all use some extra kindness in our lives. Bye for now.